Hello, in this tutorial I want to start up a new series on smart contract development. So the name of this series is called Smart Contract TDD, that is Test Driven Development. So we'll be doing all of those sort of things here. We'll code a smart contract, we test it out, not with the regular way we used to using Remix ID. No, there's not going to be no Remix ID on this. Everything is going to be coded programmatically using Hardhat or Truffle. So I'm going to show you how to do that with Hardhat for this example, and on subsequent ones I'm also going to show you how to do test-driven development with Truffle. So if you're pumped for this tutorial and you really want to get into the meat of smart contract development, I would like you to hit that like, subscribe button and hit that notification bell. That's it, man. Okay, let's head into the tutorial. Okay, here we are right now. So let's get started. The first step that we're going to do is to, of course, this is my project structure, and this is basically a starter kit that I normally use. And in this project I already have Hardhat configured, properly, and all the essential information that we need is already configured on it. So I'm just going to show you straight up. If you want to install this, basically you just need to come to my repository, and once you're in my repository, I'm going to share the link to that repository at the description, the description area of this video. So you just clone it, basically just clone that repository, and you install it using yarn or npm. And once you do that, then you have this structure available for you, okay, and you just follow the sequence that I'm doing right now. So first step you need to do is to ensure that you come here and disable this particular place here, because you will not need this rinky stuff here going on. So I don't want it to give you some error, so you just disable it totally, because you're not going to need it. The only one you're going to need is this local host, and that is the one that you're going to need. Okay, with that done, you come to this contract folder, and let's create a new contract. Let's call this blue votes dot solidity. Okay, basically what we want to do here today is we want to create a blockchain voting application or smart contract, and then we'll test out all its functionalities using the test case, the test suite called Chai. All right, so we're going to use that to test it programmatically. You see, when you're working for a company and you want to really get into, get down there and actually test out your smart contract, you're not going to be using Remix ID, because Remix ID is just for the basic stuff. So if you want to really go deep and engineer stuff and really test out things the hard way, then you have to use a test framework, a smart contract framework such as Hardhat or Truffle. But for this example, I'm actually using Hardhat. Okay, so let's get started. Of course, first step, you want to say spdx, okay, dash, no, let me just copy this basically from here, okay, and paste it here, which is what spdx, and then you say license identifier, license dash identifier is MIT, and then the solidity version is like this. So with that, next thing we want to do is declare the contract keyword, and the name of this contract is called blue votes. Okay, it's a voting smart contract. All right, so whenever I like actually defining or modeling the data of what a poll is, in building an election-based smart contract, you need a poll, and then you also need voters. Okay, a poll has certain information, and then a voter has certain information. So we use structs in Solidity to model complex data from that is neither uint, boolean, address, and all that. So you want to model it at once. So let's create a struct. Now we call it struct. That is a keyword. The name of this struct is called poll struct. So because we're actually modeling a struct, a structure of the poll. So a poll is going to have, you know, an ID. A poll is going to have an image, which makes it basically a string. A poll is going to have a title. I'm going to duplicate this, and a description. So I'm going to change it to title. I'm going to change it to description. Okay. A poll is going to have number of votes that has been done so far on it. A poll is going to have a number of contestants, people that are intending on being on contesting in this particular poll. A poll is going to have a key boolean which is deleted, so it will hold the value true or false if a poll is deleted or not. Okay, a poll is going to contain it's going to hold an address of the director. So who is in charge of this, of managing this poll? That is a director. And a poll is going to have a start at. So this is the time that this poll is starting, and this is the time that it is ending. Ends at. Okay. And lastly, a poll is going to have a timestamp, which indicate the time that this poll is actually created. So this is a model of what a single poll we have in our platform. Afterward, want to model another structure for voters. So this is voter struct. All right. So a voter is going to have what? An ID. Yes. A voter is going to have an image. A voter is going to have a full name. A voter is going to have his address. So this is the voter right here. And a voter is going to have number of votes. This is really important when you know, in a poll, the contestants, they need to they need to have a key that we keep track of the number of votes that they've augmented. All right. So, and then this lastly is going to be an array of addresses which contain voters. These will contain people that are actually voted for a particular contestant. You understand that? So people that voted for a particular contestant will be put in that array of what? Voters. All right. With that said, we want to create a key here. This is a state variable that will hold the total number of polls. So total polls. Okay. And we also want to hold total users. So users, basically, this is going to hold the total number of users that are signed up in this platform, because if you don't register, you won't be able to vote. And for you to register, you have to supply us your image and then your full name. Okay, so those are very important. And then I want to be able to hold polls. Okay, all the polls should be captured in this place, and to capture it, it's going to be a type of poll struct, but it's an array. So an array of poll structs, they're going to be held in this particular state variable here. Okay, with that said, want to declare some mappings. All right, mapping. Okay, so the first mapping here is gonna be users. So this is gonna hold users here. So this is going to hold all the users that we have in this platform. All right. So, and a user will always be identified by his address. So an address is mapped to what? A voter struct. So each user on the platform is going to be mapped to what? A voter. So this voter struct is going to contain the record of each user, and the record of each user is going to be an ID, an image, a full name, number of vote, and all this. Okay, make sure that the access specifier is public, because we want to make sure that it can be publicly accessed. So the next thing we want to do is a two-dimensional mapping. Okay, so each pole, basically, each pole is going to be mapped. The ID of each pole is going to be mapped to another mapping. Okay, and we want to what? We want to be able to know when a user have voted for a particular pole. So let's say in this user want to map if he has voted or not. So it's going to be like this. So I'll call this voted. Okay, so what I'm simply saying here, the poll ID, the ID of a poll, the ID which is this of a poll is going to be mapped, and the user, each user is going to be checked if he or she has voted for this poll or not. If the user has voted for the poll, it's going to be what? True. But if it hasn't, if he or she hasn't, it's going to be what? False. Okay, and then we want to do another one. We want to say contested. So this contested is going to what? Check if a contestant has already contested for a certain poll or not. All right. So the next one I want to do, let's copy this, paste it below here. I want to change this, remove this. So here it's going to be called contestants in. So basically we use it in checking, okay, for the contestants that are in a certain pool. Okay, and of course there is going to be an array of them. So we have many contestants that are what? That have contested for a certain pool. So this is going to what? Hold information about them. All right, and want to also check this, saying this is going to be called contestant exists. So we use this in checking if a contestant exists or not. So we're going to use an address, map an address, the address of the contestant to a Boolean value. So it's going to return true or false. Okay, so if we pass the contestant address, it's going to tell us whether this contestant exists in this system or not, or yeah, okay, this is necessary to allow a person to vote for him or she, or for him to what, do some things here. So this is really important here. And then lastly, we want to what? Check if a poll exists. So say poll exists. So the poll ID is going to be passed, and then we'll know whether this poll exists or not. Okay, because if it doesn't exist, we shouldn't be able to delete it, we shouldn't be able to what? Update it. All right, with that said, that is all the mappings that we need. Want to also write an event, which is what? Voted, right? And this voted is going to contain stuff such as a string, which is what? The full name of this person that voted, the address of this person, which is what? The voter. Okay, but I want to pass this indexed key, indexed, okay, for filtration purposes, the EVM. And then unsigning this unsigned integer for timestamp. This is the time that this particular person voted. Please take note here that you can't use commas or semicolon. It has to be what? Commas, okay, inside of an event. All right, with that said, lastly, not lastly though, but lastly, for all the peripheral stuff, we need to put a modifier. Okay, this modifier is called user only. Okay, why we're putting this? Because we don't want people that are not registered on this smart contract to be able to do anything with it. So we say register require, okay, and say users. We want to target users, this particular one here. I want to access this msg.sender person, the person that is trying to access this particular resource or function or whatever that we attach this this thing to. So whatever we attach this, whatever function we attach this to, this thing is going to be checked, okay? And in checking it, we want to make sure that what this user, is already registered in this platform. Okay, so we say this user dot voter, okay, is it equivalent to this msg dot what sender. So this is just very useful to checking if this person is registered, because if he's registered, then he'll be found here. But if he's not registered, he won't be found here. So that is what we're using to check here. So now we say you have got to register first. Okay, so that is the only requirement. And then you say semicolon. This is just very important to put here, because what these functions are is because we're going to be attaching this to a function. So this is just saying that check this thing first, check this logic first, and then continue with the rest of the functions logic, functions code. Okay, the codes that are written in that function, then it should continue from here. That is what this means here. So let's create our first function. Let's call it function. And am I spelling that correctly? Function space, and then the name of the function is what? Create poll. Okay, and in creating a poll, we need some certain parameters. First of all, this function is going to be public, and this function is going to be what? User only, so that people that haven't registered won't be able to create a poll. So this poll is going to require some certain data. So we need a string. Okay, it's going to be stored in the memory, and this is an image. Of course, we also need the title and the description. Okay, and we also need stuff such as the start at, the time that is starting, okay, and the time ends at, so the time that is ending. All right, this is going to be supplied whenever we want to create a poll. All right, so afterward, you want to quickly just do some checks and validation on the data, on the integrity of the data that you actually being sent into this smart contract. So you say bytes, and then you pass that title. It's going to condense it into bytes, convert it into bytes, and actually check the length. So there's a method that is attached to a byte data type. Okay, we can check the length of it. Okay, to tell us the length in integer. If there are things, if this title is not empty, it's going to be what? More than 0. But if it's empty, it's going to be 0. So I want to check, is this title's length greater than what? 0. If it is so, then continue. Else, okay, you should say title can not be empty. All right, so let's do this for description. The description. All right, I want to also do this for image. Okay, and I want to do it, sorry, I'm using the wrong stuff here. It's called require. Okay, not register. So now require, what are we requiring now? I want to require that this start at, the time that you're trying to start at, is greater than what? 0, so that you won't have to come and put nobody will come and put dumb data type here. And the time that is ending is definitely greater than the time that is starting. Okay, otherwise say end date must be greater than the start date. Okay, So that is good for the checking. Now let's create a variable here that we're going to use. So we'll say poll struct, and it's going to be stored in the memory. This is a poll, and we want to say poll dot id. The id of this poll is going to be basically the total number of polls, which initially will be 0, but I want immediately that I assign this total number of polls inside of this id, I want to also increment it by what? 1. All right, so now the next thing I want to do, poll dot title. The title is just going to be what? The title that is being supplied from the parameter here. I also want to do for what? For description, I want to do for image, okay, and we want to do for, you know, start time, start at, I also do for end at. Now we want to assign this director. The director should be what? msg.sender. So whomever is actually calling this function will become the director, or whomever is creating this poll become the director, and then timestamp. Timestamp, which will be what? Block dot timestamp. Okay, so these are the information that you need to create a poll. Okay, and once you create it, you now need to what? Push it into these polls. Here is the polls here. You want to push it into this array here. So now you come here and say polls dot what? Push. Okay, so we're pushing this poll, and after we push it, we want to say what? Poll exists. We want to declare this particular poll, which is this poll.id. The ID of this poll, we want to what? Assign it to be what? True. This poll now exists. So with this, we can be able to write. This is all we need to write to create a poll on the smart contract. So let's write the next function, which should be for updating a specific poll. In doing that, it's going to be basically just about the same thing as this. Let me duplicate this function here to facilitate the process. Okay, I'm going to call this update poll, and in addition to all these parameters, what I want to get is what? Unsigned integer, which is called an ID. Okay, because you need the specific ID of a poll to what? Update it. Okay, so, and all these things are here. First of all, before we proceed, I want to check for the existence of this poll that you're trying to update. So I say require that poll exists must be what? That is for this ID. This poll exists. If it does not exist, say poll not found. All right, fantastic. Otherwise, also do the same things that you've done before, and coupled to this, we want to make sure that this poll is not already deleted. Okay, because if it is deleted, you shouldn't be able to have access to it anymore. You shouldn't be able to delete it. So I'll say polls, okay, and then I get the ID. Since the ID here is starting at 0, okay, so it's gonna be what? Commensurating with what? The index of what? All the polls in this poll array here, polls array, because array starts with 0, so the ID of the first one should be, since it is 0, it's going to what? Correspond with the index here, which is what? Start with 0 too. So that was intentional, so that we can what? Make things to be what? Coherent. All right, with that said, let's come here. We want to say polls and want to get this particular poll with this ID. Okay, once we get that, want to check that deleted key, which is part of the structure here, deleted. Okay, so it's going to be either true or false. So if it is true, if it is deleted, you know, want to say that it is not deleted. Okay, it is not already deleted. If it is deleted, then we should say what? Poll already deleted. Okay, and lastly, we want to make sure that the time this poll is ending is what? Is greater than the start time, so that, you know, somebody will not come and say, okay, let's say the poll is starting on the 18th and then you say it's ending on the 17th. Let's say it's starting on the 18th of July and then ending on the 14th of July. You see, that is not a good, you know, we need to put a check on that so that we'll not be supplying wrong information. So afterward, the next thing we need to do, don't need this, we need to what? Make sure that we target the specific pool. Okay, so we don't need this either. All we need is what? For this poll here, we just need to what? Address them as polls. Okay, sorry, it's not poll, it's polls. Okay, just like we have it here. So polls. So for all this, I'm gonna what? Just update them. Come on, polls, please. So you copy it, you update all these things here. Okay, we don't need to update this too because they've been created already. They don't need to update. They don't need updating because the director will always stay the same. The time that it was created will stay the same. So we remove those. Okay, so those are the only things that you need to do. At last, you need to remove these ones because you don't need them. So with this, you've created a function for what? Updating a specific poll. With that said, let's duplicate this function again. And this one is going to be for deleting a poll. So we say delete poll. And all I need for deleting of a poll is what? The ID of that poll. Okay, so I'm going to what? Remove this and put it properly. So the ID of this poll, and I want to check that a poll exists, of course, and I don't want these ones anymore. So a poll exists. All right, that is what I need. I don't need this. And the second thing I want to check for is I want to make sure that in this post, this ID, the director is this person is equal to this msg.sender that is trying to delete this post. If it's not the person that created this post, I mean this poll, then you should say what? Unauthorized entity. Unauthorized entity. So it will not allow this individual to what? To vote. Okay. And then at the end of it, the only thing you need to toggle is to what? Say that deleted, that key deleted is not equal to what? True. With this, the poll will now be what? Seen as what? A deleted what? Poll. Alright, so next thing you want to do, let's duplicate this. Okay, in duplicating this, let's say this is what? Get poll. So this gets a single poll, okay, not a multiple poll, a single poll, and anybody can actually utilize this function. So it's going to be what? Not user only. So we're going to say that it should just what? We'll remove all these things. All right, and say you should return, say, let's say returns, it's going to be view, okay, view returns what? A data type called what? Post struct, and it's going to be stored in the memory. Okay, and all you just need to do is what? return this particular poll by its ID. All right, and after you do that, you also want to get all the polls. So get polls, and this type is, you don't need an ID here, and you're going to return an array basically. So you specify it like this, and it's not a single one that you're returning, so it's just going to be like this. Okay, that is for what? To returning all the poll. So in the first place, without you registering, you cannot be able to create a poll, delete a poll, or update a poll. So we need a function called what? Register. So only registered entities can actually create polls. So this is going to be a public one, but it's not going to be user only because it's not needed. Okay, so these are the information. What you need to pass in here, a string. We need this is going to be in the memory, of course, and this string is going to be what called image. That is the name of the argument. And we also need another one called full name. So the full name and the image of the person that wants to participate in this system must be captured. So now the next thing we want to create a voter struct, because this is a person, this is a voter basically, and we want to say store it in memory, and this is basically a user. Now I want to say the user, the ID of this user dot ID is equal to what? This total user, which will start from what? Total users, which start from 0, but immediately I assign it, I want to increment it by 1, so that the next person will take the next ID, and I want the image of this person to become the image that is coming from what? Here, and the full name to become the one that is coming from here. This voter is actually this msg.sender. Okay, and lastly, at the end of it, we want to say these users. Okay, this is a mapping here. Look at it, users here, that contains all the addresses and information of all users that have registered in our platform. So we want to say that users, and I want to create for this account msg.sender, want to assign this user to it. So this is the registration here. This is filling up forms. This is registration. All right, so with that, our function register is available. Okay, so the next thing we want to create is another function called context. Okay, context. So because only a registered user can contest in the first place, and you can only contest for a specific poll. So I want to say unsigned integer, this ID is going to be public, of course, and is user only. I want to say that first thing first, we want to make sure that this poll exists. Okay, so poll exists first, and you want to do another requirement. What is this all about? You want to check that this contestant has not already contested for this in this poll. If he has already contested, then he should not be contesting again. So I say contestant exists. Okay, this msg.sender, and if it's already in existence, then say contestant already exists. Or you can say, already contested. Fantastic. So with that, let's create a voter structure, because a contestant is also a voter. The memory, and we'll say user is equal to. So we grab this user from the users array, say msg.sender, Once we grab it, we want to perform a check here, say if condition. We want to ensure that what? That this particular contestant, does not exist. Okay? Sorry, in this place here, I want to say contested. Okay? Contested. Has this person that wants to contest, has he contested in this particular post? And then we'll pass in this. That is the key here. That is the use of this particular one here. So we're passing in the poll ID, and then we're passing in what? The wallet address of the person that is intending on contesting. So if this person has contested, it's going to bring true, but if he hasn't, it's going to bring what? False. All right, so that is what we are doing here. Okay, so now I want to say contestant exists. We are checking if it doesn't exist, msg.sender, then should go ahead and what? Sorry, not there. Go ahead. If it does not exist already, you should go ahead and what? Say contestant in this particular poll. I want to push it. So all the contestants in this, I want to include this person in the contestant for this particular poll. So this person is what? The user that we just grabbed here. Okay, we are pushing it into the what? The contestant in what? This particular what? Poll. Okay. All right. Yeah, smart contract development is like this. It's not front end development. This is back end development right here. All right. So want to say contested. Okay, want to say that this person has now contested for this in this particular pool. So MSG sender, and want to say true. This person has what? Contested. Next, want to say, contestant exists. Does it exist? This particular contestant, does it exist? Yeah, it's true now. He does exist. And we want to say polls. I want to grab this particular pool. I want to increment the what? Contestants in that pool by 1. All right. So that will get you, that will get a user able to what? Contest for a particular what? Pool. Okay. The next thing we want to create on that function. This function is called list contestant. So it's going to list all the contestants that are available for a specific what? Poll. So it's going to be public, of course. And it's a view. It's going to view it and return. What is it returning? Voter struct, because all the contestants are basically, a data type of what? Voter struct. And of course it's going to be from the memory. Please take note while we're adding this square bracket, because it's going to return an array of the contestants that it found. Okay, and then we want to check that this poll that you're trying to what? List out all the contestants, it does exist. And if it does exist, all you just need to do what? Return the what? All the contestants in this what? Poll. Okay, so that we get the contestant listed. All right, next, I want to say a function. Okay, basically this is the last function we're coding for this smart contract. So the name of this function is called vote. Okay, so this allows you to vote basically for your contestant, for your favorite contestant. So a person can only vote once for a particular pool and for a particular what? Contestant. So we need to grab the poll that it is trying to vote for and the contestant that is trying to vote for, which will be indicated by CID, which means contestant ID. And this is going to be public, of course, and it's going to be user only because outsiders are not permitted to vote. So it's going to be user only, and we want to make sure that, of course, the poll exists because you can't vote in an empty poll. And want to make sure that require that this person has not already voted, okay, has not already voted in this pool. You understand this? So msg.sender. So want to check that this person has not already voted in this pool. Otherwise you should just say what? Already voted. Okay, and this is where we keep track of it, which is here. Okay, so if a person if in a particular pool a person has voted, you will know that true or false will be the result that is coming out. So we use that in ensuring that people don't vote 2 times. Okay, no double voting is allowed. All right, so the next thing we want to check for, we want to make sure that in these polls, this particular poll has not been deleted already. Okay, so this poll dot deleted is not deleted. Okay, if it's deleted, say poll already, say poll already deleted. Okay, so and want to also make sure that this poll has not started, because okay, this poll has not expired. Okay, we don't want people voting in an expired if something has expired already. Is if a if a poll has expired, the duration, because it has a start date and an end date. So if it has already ended, nobody should be able to vote anymore. Okay, that's what we're trying to prohibit right here. So to do that, I'm just going to copy something like this here. Okay, bring it here as a requirement. Say this poll, this particular poll here, the end date is what? Greater than what? The start date. Okay, this will ensure that okay, I don't think this is very much necessary. What we needed to do here is to say block dot what? Timestamp. Okay, so that is what we need to do here. So this current time, we want to make sure that okay, the poll want to make sure about 2 things. First thing we want to do is what? We want to make sure that this timestamp, this current time, or wait, the start time, polls this ID, but the time that is starting is what? Is greater than this what? This, oh no, that's not the way it should go. So I want to say that this current time is greater than what? The start time. Okay, if it is greater than that, that means the time for voting has what? Begun, and the what? The time that this poll is supposed to end. Okay, this is actually polls dot end at is greater than what? Is still greater than what? This. So basically, this current time is greater than what? The start time, which ensures that okay, the time for what? Starting this poll has begun. People can have votes now, and we also want to make sure that the end time is still also greater than this current time. This will ensure that when this current time exceeds this the end time, it will stop allowing people to vote. So that is the idea behind this. Okay, so I'm gonna I'm gonna break this into multiple lines to make it cleaner. Okay, fantastic. So once those conditions are fulfilled, want to grab the poll, this current poll, by its ID and increment the number of votes on it by 1. I want to say contestant in, I want to grab the contestant in this particular what ID. I want to grab this particular contestant in this particular pool. Okay, and I want to what, know the number of votes. I want to increase the number of votes that he or she has by 1, and I want to also say this is what voters. Okay, still in this contestant ID, the those that are that voted for this particular person. I want to what, push in this person that is currently voting right now. So this MSG dot was sender. So I'm going to put that here. Remember, here is where, so this address here, these voters, because it's an array, so I can actually push in a new person inside it. So first, that is it for that place, and we want to say voted. Okay, we want to track that for this particular pool, this particular person has what, voted to be what, true. Okay, so that this person cannot what, double vote. Okay, I think that is it. Okay, I need to what, make sure that I close this because yeah, big error. Okay, so fantastic. So this is the entire smart contract right here. Okay, so next thing we need to do now is to what, test this smart contract out now. So let's get it tested out. Okay, in testing out the smart contract, I want you to go to this test folder here. I'm gonna remove this. Oh, hold on. No, rename this to so going back here, I'm gonna create a new file here. Call it blue vote dot tests dot js. Okay, so this is where we write our test for this particular blue vote voting smart contract. So you say expect. Okay, so basically we are actually grabbing expect from chai. Chai is a library. You know, we actually installed it. It's part of the package.json here. See this chai as promised. Okay, these are the required library, you know, frameworks for testing out our smart contract. And we're using expect because chai has what, expect, you know, expect type. It's just a type of or a way of you testing your smart contract, and you also have shield. But for this in Hardhat, we're going to be using expect. Maybe in Truffle, I'm going to show you how to use shield. Okay, now so we're grabbing expect here. All right, and we're saying const. Let's define some. Next thing we need to do is say describe. So what are we describing? We want to say blue vote. Okay, and inside of here, let's create some essential variables. So let's say let, this is gonna what, be the contract, and also contract for another reason. I'm going to show you. This is director. Director is the person that is going to be creating a poll, and this is a voter, and this is what, a result variable, which will be dynamically be used over and over again. So we want to create some constant variables. I'm going to call this open, and it's going to be what, 0. I don't think we're gonna need these, so let's just use the ID to be what, 0, because the IDs are only going to start with 0. So let's create some parameters that are going to be essential. So let's say this is the title, and the title is saying, let's say US mid election 2022. Okay, and we also need a new title. Okay, so we're going to be needing this when we're updating the smart contract. So let's say this one is just US election, and then the updated one will be 2020. And this is what? An image. Okay, I'm just going to copy a link. I'm just going to say a dummy link, https :/image dot URL, /images.urls /me.jpg. Okay, so this is a fake image. Okay, and also want a new image. Okay, let's say you, and I call it PNG. Okay, so this is what new image. Okay, and what else? We need description. So let's say Lauren Gibson Dalun Espanol. Okay, and then that is what description. And what else do we need? We need to define the starting time. Start at is equal to date dot now. This date dot now plus 360 times 1600, sorry, times 1000. So it's this, let's say it starts in 24 hours. So basically it's going to start by this time tomorrow. That is what we are saying here, and it will end, let's call this start time, and then this word ends at, instead of 24 hours, we're going to say this is 72 hours. So basically this will be 3 days later. That is when it will end. Okay, so great parameters, and I want to also define other parameters. So basically these ones are going to be for params for creating a poll, and then this one is going to be your params for registering a user. Okay, in registering a user, I need const image 1, and let's just call it https website .com /image .jpg. Okay, and then the full name, let's call this Echi Newman. Okay, so this is one user. Let's create another user. So let's call this one user 2, name 2. Why this one is going to be name 1. Okay, and all this page 2. Let's call this James Lord or days. Okay, so those are some parameters. Now that we finished creating those parameters, it's now to start writing some, test for our for the poll, for creating a poll. So let's call it describe. Okay, we call this poll, and inside here we want to write a before each. So this before each is an inbuilt function that comes with this library. It's going to run before each one of the following tests that I'm about to write execute. So why do I want it? Before each test is run, I want it to actually create a poll already, because if there is no poll, there is no need for updating a poll, or for showing a poll, or for deleting a poll. So those things are predicated on the existence of a certain poll. So let's do it. To do it, we say async, okay, because it's going to be an asynchronous function, knowing that blockchain can be slow. So you need to make sure that you put this asynchronous function, and then you want to wait for what? Let's first of all, before we continue with this place, at this place we want to do a before each one of these various categories of tests we run. We want to first of all deploy the smart contract to the web. So we say, okay, contract, this one that we created above here, is equal to await, okay, eaters, dot get contract factory. Okay, so this knows exactly where your smart contract is, okay, and by its name say blue vote. Okay, so it will grab your blue vote contract, and I want to also grab in some accounts. I call this one director, and this one to be what? The voter. Okay, I'm grabbing it from this same eaters dot get signers. Okay, this is going to return an array of available accounts on the network that you are on, this local network that you're about to deploy this smart contract to. So we can put this here. Okay. Next, we want to say now this small contract keyword now equal to what? Awaiting this contract, this one dot deploy. So once it is deployed, the instance of that deployment is not going to be stored in this small contract keyword. So this is very necessary before we proceed to this place here. Okay, yeah, this is where we start writing is the set of contract for this pool. Okay, in doing so, let's write our first test. So we want to say it, okay, sorry. So what it should confirm poll creation, and this is going to be an asynchronous function inside of here, callback function. So I want the result, I want to check, after the deployment, because we need to be able to first of all create a poll first before we can know. Because if you look at here, remember this array is going to hold all the polls that are created in this smart contract, and then we can use this particular function here, this function called get polls, to return all the polls that are stored in this polls array. So if the length of the array is greater than 1, that means that a poll exists. But if it is 0, that means there is no poll existing in it. So we want to test that want to check if a poll exists. So we'll say await this contract dot what get polls. So I'm actually calling this function here get polls. Okay, I'm calling that function, and once it will return the result and store it here. Now I will use my char now to do expect. I'm expecting that the result that is coming from this pool, the length, I expect it to have, okay, to have what? A length of 1. Okay, so if it does not have a length of 1, that means there's something wrong with what? That it means that there is no poll in this smart contract. So I'm going to save it and test it out first. To test out a smart contract, you just need to write this yarn. I'm using yarn. If you're using npm, you can use npx. Okay, so I'm using yarn add at test, and I run it. So it's failing. It's saying that this thing called modifier expected a semicolon but got modifier. So when we come to this place here, right at line 45, you see how cool this is. Without using remix ID, it's telling you where the error is on line 45 right here. So the point is I was supposed to supply a semicolon here after I created that event, but I didn't do it. So now the compiler, the Solidity compiler, is actually warning me. So now I clear it and I run that again. You see it failed. Why did it fail? Say unnamed return variable can remain unassigned. Add an explicit return keyword. So let's come to line 104. So I was supposed to supply return here keyword, and I also want to supply return keyword here. Okay, so now that has been resolved for those 2 places. So now let's clear this and actually run this again. Come on. All right, so let's run this again. Yarn Hardhat test. Oops, okay, there seems to be another problem. It's a warning. Basically, it's not like an error. So let's say we just give it some name. So let's call it poll, and let's call this one polls. Okay, let's save that and let's see this in action. Run. Did it resolve it? This declaration shadow an existing declaration. So I think we should do this. On that. So it kind of compiled successful though. Okay, let me clean this. Let me bring this back. Clear this. Okay, run this again. So okay, it's actually working now. So those errors are gone, but it's saying that before each hook should confirm poll creation, and it's failing. Why? Failing because cannot connect to the network localhost. So we need to first spin up a localhost, a Hardhat node. A Hardhat node is the local blockchain server which the smart contract will put in for the testing to be what? To be successful. So you say yarn, open another terminal, say yarn Hardhat node, and then you run that. So it has started. Okay, so that is the local blockchain there. So now we come to this place here, we clear this, and then we'll run yarn Hardhat test. So it actually went this time, and it's saying that to confirm, it says that what assertion error, expected what? Expected an empty array to have the length of 1 but got 0, so that means there is no poll that has been created. Okay, so this test failed because there is no poll that has been created. So because we need to create a poll first before what? Test out this thing. So we are using that same thing called what? Before each here. So let's create before each function. Before each, what should happen? Want this to be asynchronous, of course. Before each, there should be what? The creation of a poll. Now we say await, want to create a poll. Say contract dot what? Register. Remember, okay. Now let's first of all let's actually create a poll first. Okay, create. Let's copy the name of the function. Come here. So this is the function that we want to model. So create poll. Okay, we're querying this function, and in creating a poll we need what? An image. Remember, we need an image, the title, a description, a start at and end at. Okay, so we say image, title, description, time that is starting at and time that is ending at. Okay, so and we need to specify who this is coming from. Okay, we need to specify it, so we say from this director. Director is one of the accounts, remember, and the address. So we are grabbing it from what? This is the address that we want to what? Want this address to be the person creating this particular poll. So now let's do this, and okay, to do that let's save it and actually run the test now. Okay, it failed. Why did it fail? It failed with this reason: you have got to register first. Remember, because this is what a criteria that must be fulfilled before anything. Before this person comes to what? Create a post, he must be a user that has been registered already. So we need to what? Register this user first. So basically this is what a user, anybody that is going to be interacting with this thing on your DApp will be facing. Okay, so we are actually programmatically testing out the reality here. So first of all, I want to say await. Okay, this contract dot, we're actually trying to register this person first. So this register here, and in registering a person we need what? His image, his full name, and then his address. So we'll now put it here. Okay, I'm going to say image 1. Okay, this is a user, and of course, and his full name is what? Full name 1. Okay, so we're registering this is going to be the course. It's going to be this the director. Okay, the director also needs to be registered in the platform before he can what? Actually create a post. So now let's actually run Hardhat test. Woo! Okay, now you see that passed successfully. So with this now, we know that before we create any before we actually run any test, the poll this user must be registered first, and then the poll must be created. So with this, let's test out the next poll. Let's create another test, and this time we want to be able to update a poll. So I want to say confirm that a poll updates. Confirm poll updates. So in updating a poll, what and what do we need? So in updating a poll, we need all the things that we needed in creating a poll plus the ID. So we come here and say, first of all, take await contract dot update poll, and in updating a poll, I'm going to need basically all of this. let me remove this here. I need all of this. Okay, I'm gonna need all of this plus the ID, which is actually what 1. But I don't want this ID. What I'm gonna do to grab it is I'll first of all, grab a particular pool. Okay, I'm gonna grab contract.getPools, but I'm not saying get pool. I'm gonna get pool, one particular pool. I'm gonna pass in that ID of 0. You know that ID of 0 is actually this one here, so I'm going to pass in 0 here because the first pool to be created will be what? 0. So I'm going to say the result dot what? ID. That is what I'm grabbing here. I'm going to pass it there, and I'm updating the image to what? A new image, and then the title to a new title. So those are the reasons why I needed to update in the first place. So once it is updated, I want to grab that particular poll again using its, because when I grab it this time around, it should be what? Giving me the new information that has been updated. So I expect that this result dot title, okay, so now equal this new title. But let's see if it's still the same as the old title and the what, and also the image. If the image is still what, the old image. Okay, let's save this and what, run this thing. See that? Okay, you see that? It expected what? Let's see title. Let me comment out this one. Run that test again. So it failed. Why the heck is? Oh, wait a minute. For each creating a pool. Creating a pool, image comes first, right? Image title. Title. Image title description. Okay, so title, new title, image, new image. So yeah, this is a new image, and this should not be new image again. This should be new title. Okay, that almost deceived me. Okay, so now we're passing new image and new title because those are the parameters. I was passing new image twice, which was not right. So now let's clear this and let's run that again. So you see it failed. Expected, this is the updated value, but and I was using midterm. So basically, if I say this title now should be what, equal to this new title, and this image is equal to a new image now. So when I save that and run this thing now, like passed, okay, because the title has now been updated to the new one. That is how you're using validating that you were able to actually update a poll. So now that we've updated a poll successfully, let's delete a poll. Okay, in deleting a poll, I'm going to grab a poll. I'm going to actually grab it by its ID, just like I did here. Okay, so I'm going to grab this ID poll, and once I grab that poll, I'm going to wait and say contract dot. What am I trying to do now is to delete. So I'm going to copy this name of this function. So delete poll, and then I pass the poll ID on it. Of course, I also want to pass in the person that is deleting this poll, which is here. Okay, once that is deleted, now let me check, let me make my expectation. I want to still grab this particular poll. After I grab it, I want to check for the deleted status. Okay, so I say expect. I'm expecting that this result dot deleted. Okay, the deleted status of that poll should now be what? Equal to true. Okay, so if it actually passed, if it deleted correctly, it should change from false, which was default, to what? True. But let me test it for what? False. If it remained false after the deletion, let's clear this. Let's run this. See, it fails. You know, expected true but got what? False. So it actually what? Went from what? So what it means that if I have not deleted and then I run this boy here, you see, and then when I run that, it actually passed, because by default that poll is not deleted. Deleted is what? False. So now that I open this and I run this, it's going to what? Fail, because it's what? Now deleted. So I just need to change this to what? True, and save and run this boy again, and you see that it worked successfully. So, and that is what? All the things that you need for what? Creating a poll. I'm going to create a different category of text again, and okay, let me call this describe, a describe block, and I'm going to call this candidate. Okay, and here let's get to work here. So before a candidate can do anything, that candidate has to what? Register. So I'm copying these same properties here. So a candidate must be what? Must be registered, and a poll must be created before we do all this business. But I don't want, I want to register the second person to the voter must be registered. So I'm going to say this registration, I'm going to say .connect. Okay, why I'm saying .connect? Because in itas.js you have to what? You have to actually pass in, if it's not a primary account, like the account at number 1 here, you're using the account number 2 here with this method that I used before, it's going to bring out some error. So, but yeah, you have to use any other account, you have to connect it using this method here, .connect. So I'm passing .connect and actually passing this voter, which is here, this particular voter, I'm passing it here. And I don't really need to do this anymore. Okay, so I'm saying contract.connect this particular what? Address, and register this what? To be image 2 and full name to be what? The second one. Okay, once that is done, that is really necessary for running any other what? Test cases here. So for our first test, let's write this it. Okay, should confirm ability to contest. So we want to confirm that a voter can contest or in a poll. Okay, in doing that, you say an async function, of course, a fat arrow function here. And now let's test it out. We want to what? To contest, we say await that contract dot what? Contest is a function there. So basically what we are doing, we've done this register function, we want to do this contest function here. So we say contest, okay, and what are we contesting? We want to pass in the what? We want to pass in the poll's ID, so the ID of the poll, which is that, and then the director, want the director to be the one contesting. So I'm just going to copy this here. Okay, so I want the director to be the one contesting, and I want the voter to be the one voting for the director. So I'll pass this. Okay, so after this here, I want to await this smart contract. So I want to actually contest for the both, let the both parties the contest, and then we know how many contestants we now have in this pool. So let's say connect again. I'm passing the voter this time, so don't need this here. Okay, and after this, I want to list out the number of what contestants in this platform. I say await contract dot list contestant. So I want to be able to what? Now list the contestant for a specific poll. So I say list contestant, I pass in the poll ID. Okay, and once that is done, and I expect, because it's going to be bringing an array for me. Okay, it's going to be returning an array. As you can see, it's going to be returning an array. So now when it is returning an array, I want to say expect the result to have a length of, should we say 1? Let's do 1 and check it out. Okay, we do that and save, run this. It failed, saying that as I expected 2, because we contested twice. 2 people contested, the director contested and the voter contested, so it should be 2, but it got 1. So I'm expecting 2 contestants, so it should be what? 2 here. So when we run this, see that all of them, they passed successfully. Fantastic. But not yet. Want to also ensure that if I get this poll here, so I await contract dot get poll. I want to get this particular poll here, and I'm passing the ID of it. Okay, I expect that this poll, the result dot contestant okay, dot to equal what? 2. All right, so let me show you what is happening here. Whenever a person votes, contest, remember what is happening here. This poll.id, this particular poll, the contestant is increased by 1. So because we contested twice, the contestant of that particular poll now should increase by 2. So if we say 1, see that it's going to be what? Erroneous. See that it failed because it's expecting 2, but it got 1. So we bring it back to 2, save, run that, see that it all passed successfully. So now that it passed successfully, let's write the next test for it. Okay, this time around we want to be able to confirm that we can vote. Okay, that we can actually vote. All right, so we come here, and now in voting, ability to vote. In voting, we want to first let there be a contestant first. We don't need this person contesting again. Only need one contestant. Okay, and in contesting, once we contest, we want to list out. I want to grab the first what? Because this is an array, I'm going to grab the first contestant. Because we only have one contestant, I'm going to grab the only contestant there, and I want to check. Okay, let me remove this. I expect that the voters, because nobody has voted for this contestant yet, so I say expect that the voters for this to not include, okay, this voter dot address. Okay, remember here that the voter is actually an array, so I'm using this chai test expect to actually check the array. If it doesn't, I'm expecting it to not include this voter right now because I have not voted yet. This voter has not voted yet, so there should not be a voter yet. Okay, so once that is done, now the next thing I want to do, I want to actually vote. Okay, so I say contract dot vote. Remember, and I'm passing the ID. Look at here. This is the vote function. It takes an ID and a contestant ID whom I want to vote for. So I pass in the ID. So not only this, I also want to check there is this thing called votes. Okay, this keeps count of the current number of votes this particular contestant has. So I want to say to equal 0 because nobody has voted for him. So to equal 0. So as of now, let's actually vote. All right. So now, but if I actually run this, it's going to pass because it's not passing. Voters. Cannot read undefined property. Voters. So what is going on there? So let's do this. Instead of doing this directly, let's say result is equal to what? Result, and I'm grabbing the first member there. Now let's run that again. Okay, it actually worked now. So we need to store the result first because as of this point we've not gotten it because this is actually a blockchain and a synchronous function is delaying. So as of the time of putting it into this putting it inside of this variable, it has not been retrieved yet on the blockchain. So now that is working, so now let's contest, let's vote. Basically, I'm passing the ID, and I also want to pass in the ID of this particular voter. Okay, so I'm passing the ID of this particular voter, but the person that is going to be voting is what? From the voter account. So I'm going to say voter here. So the voter is the one voting. So now, of course, I'm going to say await here because this is what? A blockchain based stuff, and it should be asynchronous. So now that is done, let's check out this again. Okay, and see that as of now, I expect it to have is not to have anymore, and the number of votes should now increase by 1. This is what I expect. Okay, so now let's run this. Okay, it failed. It's saying that end date must be greater than what? Start date. So because the start date is actually supposed to be tomorrow, it will not allow you to vote until that tomorrow. So what if I just bring it to right now? Okay, the current time, as the time of creation is already what? You can actually actually start voting at that time. So because it's actually today. So now let me run that again. Is this saying end date must be greater than, so let's subtract some certain data from this. Let's say it was yesterday. Let's say divided by 24 instead of divided by 24 instead of multiplied by 24. So clear. Run that again. Okay, that failed. So let's say we minus 1000 from it. Clear. Run. Okay. Now so for now, let's first of all let's comment out this particular criteria and actually test out our voting functionality, because that is what is giving us error. So let's clear this and let's run the test, and that was successful. So the idea here is that this is actually being set to be what? To be voted for by 24 hours from now. Okay, which I first of all I am removing. So now from here, let's try this method. Let's first of all bring back this comment, and if it doesn't work, we'll just move on. And let's say set timeout. Okay, so let's say after 5 seconds this function should run. Okay, it will also be synchronous. Okay, so now let us run this again. Oops, it actually worked this time, because we needed to wait a little bit so that this block.timestamp will actually be greater, because if we do it immediately, then the time will be too short for a difference to be met between the time that this current block time and the time that it's actually starting. Okay, so you get it. I hope you understand the gist. So I'm actually delaying just a little bit more before I actually run this other one here. So let me just reduce the time to 2 seconds delay. Okay, let's try that. Okay, it worked. What about 1 second delay? And let's try that again. It worked. What about 0 seconds delay? Would that work? Let's see. Oh, it actually worked. Basically, just putting it here. Okay, what about I just comment out these things and let's see. Run that again. Oh, you see that it actually failed. Okay, so basically it's because of this little delay. This function set timeout function is introducing a split second delay, which adds into the advantage of meeting this particular criteria here. Okay, and this criteria states that the current time right now must be greater than what the start time. So this makes sure that it is the day or it is the time for people to be for people to start voting for their contestant. And this other one is only ensuring that the end date, the time that the stipulated time for this particular poll to end has not yet come. So so long as this poll's end time is still greater than the current timestamp, that means it is still open for people to come and vote. So this little introduction of a delay here, let me just put it 1 second, resolves that matter for us. Okay, and with that, basically we just run this one more time and okay, run that. See, all our tests passed successfully, and that is how you actually do test-driven development with what? Hardhat, and not getting yourself constrained using Remix ID. Okay, that is it, man, for this tutorial. I hope you've gotten ton of value and you've understand the key idea of what it is required in the industry for you to equip yourself in writing smart contract. So if you be writing smart contract for a company or a Web3 company or stuff like that, you need to know how to test that smart contract. We test tools such as Hardhat or Truffle, and in this tutorial I've shown you how to use Hardhat to do it. Okay, after you do it now, you can now you can now actually start integrating it into your Web3 project, because you validated that all the functionality, the core functionalities, they are working. I actually use this smart contract to create a decentralized application, and this is how it looks right now. You can enter, you can see contestants there, and the point was this: when I was checking it out on the previous code, I found out that there was a little bug in our smart contract that was obstructing users from entering into different pools, from contesting into different pools. So I looked at it and I removed that and just worked on it a little bit, and when I did, I discovered where the bug was coming from. So I fixed it and it's working great now. So I just want to show you how I did that. How I did that was here. Okay, first of all, let's come to this place of contesting. Okay, this contestant, this if statement, this is where the problem is. Okay, the contestant exists and this particular one contested, they serve the same purpose. They serve the same purpose, but this serves a better purpose because this is obstructing multiple users from entering, because this is targeting for every pool. This is only targeting for the entire system, and it's destroying our work, you understand? So we need to remove this. We also need to remove this, and we need to remove this. After you remove those, okay, the next thing you need to do is to come to the above here where it is listed and contestant exists. You remove it and then you save. Okay, so with that done, all you need to do is to run your test and to confirm that everything works. So I will do yarn Hardhat test, run that. Okay, it all worked out just great. So I just wanted to make that little correction, you know, because it's really important. And with that done, you're good to go, you know. Yeah, smart contract, TDD, test driven development. All right, I'll see you in the next tutorial. Bye. Hey, make sure you like, subscribe, and hit that notification bell. Right.